Let's get going with the next set of exciting talks here. My name is Swarupa Gollapalli. I'm a security program manager in CNAI Security. I'm honored to introduce the next speaker, Jon Hawes. He's flew here all the way from London. He runs the detect function at Photobox Group, which covers security operations, incident response, and red team testing. He also leads the Security Innovation Hub, running projects to evaluate technologies and processes that support data-informed decision-making, process automation, and a DevOps engineering culture. It's all yours, Jon. Welcome.
Hello, everyone. Thank you very much. So, I am here today speaking on my own behalf, not that of the company that I work for. We are going to jump fast into some very philosophical territory because I have recently been thinking about a disconnect. It's the disconnect between reading things like this and thinking, yes, that is definitely where we should be. However, if we're honest with ourselves, very often, perhaps we find ourselves somewhere that's slightly more like this. Now, I think directionally we know in security that we're doing the right things. So clearly we shouldn't be changing the game, but I do think we have some work in security to understand what the games are, understand where we should be playing what game and when. So how should we think about that problem? Well, I propose to you that everyone is a security architect. It's just that not everyone knows it, which means if, like me, you work in the space of detect, respond, recover, you are about as far downstream as it gets of conscious and unconscious architecture decisions. But architecture of what, you ask? I would answer that the clue is in quotes like this from Dave Eitel, which is the system of systems that we find ourselves in. And I have, as I've worked in security, come to think of the web of security controls we work as a complex system operating in a complex system. This is a talk about how data can help us, about why graphs are absolutely necessary, but perhaps why they are necessary but not sufficient until we overlay them onto maps that help us understand our terrain, specifically so that we can begin to answer questions like this. So, what is the mission that we have as security professionals? Well, the best articulation I've found of it is to strike a balance for our organization between protection and spend. And in order to do that, I would argue, in order to achieve that balance, we need to understand the terrain we're in, understand activity across it, understand adversary opportunity within it, and then figure out, based on all those factors, what are the things that we're going to have to deal with as we begin to strike that balance. Here are a few of them that I wrote down, but the deal is that these are changing all the time. So while it's very easy to draw something like this that shows a lovely level of protection increasing as the spend goes up at the beginning, as we begin to put our security program in place, and then it begins to fall down in a nice curve, the reality is that means getting our security control implementation correct over every single control we put in place, its entire lifespan, the particular portfolio of controls that we've decided to implement, i.e. where we put our money, and of course how those controls work together as feedback loops to provide the result that we're after. So, if we want to reach that worthy destination, what are we going to rely on for the job of the reaching? I think it's how we translate our understanding into choices that drive decisions and actions. And here are some of the questions we need to answer as we do that. Where do we place our resources on our field? In what pattern? How do we direct their effort? Why here, not there? Why in this direction, not that? Why this much, not less? Now, even just talking through those questions, it's fairly obvious that we can't answer them by using a spreadsheet, which is why we end up with Excel macro mirror mazes of spreadsheets joined together, which is essentially a graph that we have built and then filtered through, applying our mental model of understanding. And if we think about what that process really would be if we kind of wrote it down, I think it would look something like this. Data captures, information tables, knowledge graphs, understanding maps, and wisdom filters. And there's a sense that it should get easier to do the things we're trying to achieve as we go up this chain. I didn't write this. This was actually taken from my friend Dan, who also added that the future perhaps is owned by cartographers who can navigate maps and refine paths through them by filtering. So what is a visual metaphor for that? Well, this is the best one I found. This is a hill mapper from San Francisco. It gives you your location. It tells you the rough gradient of the hills based on your location. And you can then select, right, well, if I want to get from A to B, here's the wisest way of doing it. And obviously, if you're a cyclist, that's the very handy thing to do in San Francisco. So there are some explicit things that we can probably take away when we look at that map. Well, it's obviously going to be harder or easier to do certain things in certain terrains just because of the terrain. It's obviously going to be harder or easier based on our position in that terrain. But there are also implicit things about terrain, which is, what are the forces that act upon them? Who controls that terrain? How do they perceive it? What are their concerns and pressures? How are they making decisions? What actions are they taking? And how is that changing all the things we need to understand to implement the best portfolio of controls that we can? So coming back to our perhaps rather depressing lives, if we're not gifted with working in a wonderful organization that just gets it and all the controls are effortlessly implemented and there's absolutely no technical problems at all, and coming back to what that may mean if we're running detection and response, I think there's another question that we haven't yet asked ourselves as an industry, which is, what are the range of forces that we are at the mercy of, can influence, or can conjure? And in my work so far, I've come to think of the forces as three. Tectonics, weather patterns, and microclimates. Obviously, these all have different scales of change, and they all have different predictabilities of change, which is why you should not make tectonic decisions on a golf course. So if we are waiting to drive change in our business, do we, as Milton Friedman once suggested, wait until the politically impossible becomes the politically inevitable and be there with that plan for when the bad thing happens? Well, I would suggest that that is reactive, and we want to be proactive. And if we want to be proactive, what are some of the ways that we should be thinking about the problem that can help us? So there is a presentation that I want to write called "You Should Never Quote the Art of War Unless You Have Read the Art of War." And unfortunately, that is not this presentation, but I promise you I have read it. And I'm just going to pull out a few quotes from it that I think are helpful metaphors for us to think through. So what the Art of War tells us or suggests to us is that there are flows of forces and shifting configurations. Changing patterns, right? It tells us that if we can see the simple things in those patterns, we can change the whole configuration very easily. So if we can understand patterns, we can harness them. And it tells us that if we're ready, change can still happen super quickly, and it doesn't have to cause chaos, and it doesn't have to wait for chaos. And if we think about what graphs are to our industry, I would propose that graphs are essentially the bridge between being able to be reactive and being able to be proactive. And that's because they offer a scalable way for us to structure, connect, identify, and share patterns with each other, both about the environments we work in, but also about the attacks we face and the patterns we're seeing. So this is kind of a follow-on presentation to a presentation we did at B-Sides. We presented an ontology. Here are the components. We were basically trying to take all of this stuff, which is a list of the stuff we wanted to put in a graph and all the various metadata associated with it, and we were trying to codify how to link data in the business and technical dimension to identify patterns better for ourselves, right? So all of this thinking has come out of operational requirement to solve a problem. So it's not academic in that sense. And if you want to have a look at some of the ontologies, they're on GitHub here, which explains kind of the nodes and the edges and or the nouns and the verbs that we use to build up that ontology. And what that did was it allowed us to effectively capture our terrain, begin capturing it. And it allowed us to begin to understand influencing factors within our terrain about decisions that were being made, about business projects, about business change. What it didn't allow us to do was to understand the merits of moving in a particular direction, choosing the patterns that we wanted to implement. And so something that I feel is an untapped area of where graphs can help is patterns of play, right? So a question that I ask myself very often is, well, how do I reduce adversary opportunity in the terrain with the greatest efficacy, right? It's not a question that keeps me up at night, but it is what I choose to sit up at night working on. And so let's assume that we've done a basic threat model process like the one that Chris Hoff and Phil Venables talk about here, if you've seen this work on Twitter. And let's assume that we've decided that we're going to act. Effectively, we're hoping to reduce exposure to unacceptable impact, right? That's kind of our job, stop impact, deliver protection. And if we think very simplistically about what we're doing, when we do that, we're probably taking things that are interesting to the attacker and easy to compromise and moving them from one point of this quadrant to another. Simple enough so far. So recognize one-to-n patterns, implement one-to-n patterns. Now, generic of the terrain, we've already talked about a few things that are going to determine your success when you do that. However, one of the ones that I've been thinking through recently is the game space in which we choose to counter adversary opportunity. So how do we reason through, typically, the patterns that we apply to our environment to achieve the result we want at best cost? And also, something that I also find challenging in this industry is we don't have a good way yet, other than by creating slide decks that are hundreds of slides long, to present the models we have in our head to our execs, to our colleagues, who are being asked on top of all their other responsibility to now consider a threat in your environment. It's like, well, hey, I'm a software engineer, I'm the CEO, like that's why I have you there for, right? So we need to expose the patterns that are available to our colleagues and the choices and the costs and the implications of those, because if we can't, we look like a black box that goes, hey, we should put in this EDR solution, which, is fantastic. So here's a simple way that I've kind of been walking through this that I wanted to share. Let's take, basic like attacker, motivation, right? Very simplistic level. I know that nation states have different motivations. This is an incomplete model, but it begins to help us think through it. Let's take the concept of at every different layer of attacker, there are different layers of sophistication. Those attackers have access to different TTPs. And then let's take the concept of not attack surfaces, but threat exposures. So those actors can reach different exposures. It's not going to be possible for a script kiddie to jump on a plane, go to another office in another country and break into it, whereas that will perhaps be possible for a nation state, just as a thought exercise. So if we combine these models together, what we get is something like this. We get level of sophistication going down the x-axis, attack surfaces on the y-axis, and we begin to understand, right, what is our level of sophistication, for example? Where's the place that we feel is defensible? Where do we want to get to with our level of protection? And using something like Sunil Yu's cyber defense matrix, we can peer inside a specific threat exposure and say what controls are doing what across the various layers of access network, devices, apps, et cetera, and how is that pattern moving in relation to the key NIST pillars of identify, protect, detect, respond, recover. And we can also start questioning perhaps the efficacy with which those controls are achieving that result. For example, if there's a huge amount of waste, we might look at repurposing spend onto another control or another threat exposure. If there's something that looks great but needs to be optimized, how would we do that? And are our controls focused on the right areas across the cyber defense matrix for the threat profile we have? This is the job of threat modeling, to give us that information. But basically what we get to at the end of this is efficacy in relation to a range of possible options. And the best way that I've found recently to think through what those are is this. So this is again from Sunil Yu. It describes vectors, exploits, attack surfaces, and vulnerabilities as different game spaces, although that terminology is mine and not his. And he describes the rate of change across these different areas. So attack vectors change very infrequently, but when they do, they destroy entire control configuration patterns. Vulnerabilities change much more regularly, but the control patterns you can use to control them are much more stable. So the example he uses, imagine a prison where the vector is aerial attack, so you can kind of fly a helicopter to Alcatraz, for example. The exploit would be the helicopter. That's the thing that allows the attacker to get there. The attack surface is all the places they could land that helicopter, and the vulnerability is where they choose to land their helicopter to achieve their objective to extract the person they want to get out. Now, an example of a change in a vector would be drones. So drones would collapse the model that a prison like Alcatraz may have built to protect against aerial attack, for example. So that's kind of the rough thinking framework. So if we combine that dimensionality with the cyber defense matrix, and we think of it as a 3D space, and we think of the various efficacy that we face if we can protect against the vector versus protecting against the vulnerability, what we begin to understand is actually our controls and the patterns that we can put in at all these different threat exposures can be wildly different and multitudinous. There's clearly a lot of them. Not only that, but the way that we apply them to an upstream threat exposure, like our entire external internet surface, is going to have a knock-on effect if we don't apply them correctly to the internal surface. So I want to kind of give a quick thought experiment here. Let's take this picture, and let's say that we move the things that are interesting and easy to compromise over to interesting, because we can't change what the attacker is interested in. There is a model that we can, but I don't have time to go into that. And what we end up with is this. So one of two things is going to happen, right? The attacker is going to change what they're interested in to achieve their objective, or they're going to have to just work harder to effectively compromise those things that we have made less easy to compromise, right? So depending on how we choose as a business to implement controls and the scale of our business and the attackers we work with, how could your actions change how good everyone's adversaries are? Not to answer now, just think about. How could the actions of others change how good your adversaries are or what they're interested in? And how could threat actors just change what they're interested in? So when we think about things like the release of government-built tools and the availability of script kiddies, when we think about the fact that some organizations who were very good at counter-fraud back in the early e-com days were effectively training up attackers at a speed that the rest of the industry could not keep up with, and therefore, effectively collapsing vectors for those other organizations, we need to begin to consider in the wider picture, what is the stability of our control capability portfolio? Are we making the right trade-offs when we're applying patterns? What fast and slow cycle changes are we ready for? And are we happy with all those answers? Now, that is not a Rubik's Cube. That is playing 50 games of chess concurrently, where every change on one board may actually influence the patterns on the other board, so when you go back to them, they're no longer the same. And that's a complex space. And yet, what we have to work with to solve this problem is the riskatron that generates red, amber, green, awful dashboards. I literally do not know how the product managers of these companies manage to get away with pie charts and kind of like weird global things that no analyst can use, and then loads of alerts. It's very confusing to me. And it's more confusing because of where I find myself in the battle for meaningful, timely insight. Because if you consider the fundamental functions, maybe, of what we do in these different spaces in NIST, I would argue, like, if a data system was going to emerge, it would have emerged here. But instead, as where we have this kind of incoming amount of volume that demands context, I have false positive as a service. That is what my solutions deliver to me, and I have to spend most of my time engineering out. And that is only the beginning, because once we've got one of those, well, that's not enough. Surely we should put all those alerts in an inbox. No one knows where they're from. Oh, well, hang on a minute, let's put them all in a SIM. Yeah, and still no one knows where they're from. Oh, let's buy a niche analytics vendor because our SIM doesn't work. It's useless. Well, we'll build a data lake on open source. Isn't that fantastic? Maybe none of that's work. Come join our hunt team. But I do think that that has an interesting implication. Because if we look at the space that hunters are operating in and the kind of things that they're trying to use a range of tools for, one of which is graphs, that's not to say they don't also have to use lists and tables, we can ask, why are they not succeeding in surfacing and driving some of the change that they find through the graphs that they're using? And I would argue it's because in the hunt space, very often those graphs have partial context. They're driven from the bottom up, and they can't connect the business and the technical context in a way that's able to create those changes in tectonic shifts or in weather patterns that we're interested in when we think about applying the most efficient configuration of controls and winning the business case to do that. And I think that's particularly relevant when we think about evolution, because as Phil Venables said in a recent tweet, a lot of the stuff that happens to us is entirely foreseeable. It's not some amazing new vector that comes at us. It's the same stuff that has been coming at us for ages. And indeed, it's stuff that we thought there were controls there to stop. So when we think about how data science and graphs and analytics can work with us, I think very often, when we hear comments like that, we're thinking, right, well, that's an unexpected outcome in hindsight. We thought that something was there that wasn't. Effectively, if we want to go, we could say there's a step in an attack path that we thought that we would be able to detect and that we thought we'd be able to respond to. We could ask ourselves, what went wrong? And we might say, well, let's look at the different layers again from Sunil Yu of sensors, analytics, orchestrators, and actuators. Sensors effectively an agent, analytics, for example, some ML, orchestrators, the workflows, actuators, the thing that do the blocking or the stopping. Oh, my entire grid has disappeared here. Sorry, it's all red anyway, basically. So we might say, oh well, if we did detect it but we didn't respond to it, that was a workflow problem, right? So we had a problem with orchestrators. We had a valid detection. Perhaps here in this space, we might say, oh, well, the alert was ignored. We did all the right things in the workflow, but it was just the action we took at the end. That's a problem with our actuator. We might say, that's a successful detection and workflow, but wrong action. Here, gap or failure in detection logic, right? Maybe that's what we blame it on. And we say that was a problem with our analytics. And here, we might say, well, the reason that we found this out was post hoc investigation into something else. We didn't recognize it. We didn't have the data. There was a problem with our sensors. We had a gap in our data collection architecture. Our data wasn't available. But if you go ask your team, why they missed what they missed. And if you're on that team looking at what you missed and thinking about that, I think the answers that we find might be very different. Typically, they're like, yeah, well, we were advised by the vendor to turn the sensitivity of the ML algorithm down because it was just generating too many alerts. Excuse me. Vendor won't share the detection logic. Hey, would it be possible for you to explain why you didn't detect this? No, we wouldn't do that. It's too secret. Okay, great. So you failed and you won't tell me why. It looks innocuous. We've seen this 1,000 times. That looks normal in our environment. And so when we think about failures at these layers, and when we ask ourselves searching questions about are they invisible or are they known? Are they silent or are they loud? Are they consistent or inconsistent? Are they local or global? And what layers did they happen? And how can we safeguard against that? And wouldn't it be great if we could do continuous controls monitoring against our entire environment? We have to ask in the space of data analytics, ML, and graphs, what are our controls? And the answer is, it is a mixture of human and machine. And I would ask the question, how do we begin to put assurance on humans? That's not a simple question to answer. So when we think about defense data science, the model that I think we should be following in this is akin to what Jon Hawes recommended in a paper a number of years ago, when he says, what I'm interested in is how people navigate the boundary between themselves and the machines they work with. And as we observe our use of our tools, that is a focus in and of itself. And that is the focus that I am interested in, and I'm trying to use knowledge graphs that connect the technical and business perspectives of what we're doing to better understand what those patterns are. So when you think about that problem, it's very clear that it's not an easy problem, but I do propose and I do agree that it is a problem about human interaction, data science, and data engineering, albeit not necessarily a question just about models from a technical perspective, but models from a human perspective as well. So if we think about what we're trying to connect, and we think about the times that we end up joining tables together to create graphs that are essentially graphs in Excel spreadsheets, and we think about what hunters usually uncover about why something got through, or the failures that they find in control or data availability, it's clear that they are beginning to enter a different problem space, right? So when you see technical people using graphs and they begin to uncover these problems, they're entering a strategic problem space. And I think we are not yet at the point in security where we're thinking properly about the use of signals and applying them to populations to begin to make it easier for the robotic side of our analytics to be more effective. So I'm not going to spend too long on this. I'm literally just going to flash these up. But Allspor also wrote a reflection on feedback loops for resilience. So these kind of 4 lenses of resilience that we can think about. And if you take those and you think about what that might mean if we think about the robotic side, so again, copied from Sunil Yu. This is by no means right. I just kind of like, well, hey, let me put this together just to demonstrate how I think we should be thinking. We need to understand what problem space we're living in, right? How can we use signals to best effect? How do we partner with them rather than become slaves to them? And the way that I've been thinking about this recently is roughly this. So we have signal strength, signal density, and signal similarity. These are the 3 things that I have to work with. Let's just take 2 of those dimensions. I would propose that dense signals and strong signal strength puts us in a bounded problem space. There are also unbounded problem spaces and wicked. If you want the definitions of those, here they are. What that means is that across those problem spaces, we're going to be dealing with tactical, operational, strategic, and grand strategic problems. All of these have different time horizons. Grand strategic is probably 2 to 3 years. Strategic is maybe 1 year. Operational a few months, and tactical and so on. When we think about the kind of decisions or the kind of movements that decisions in these areas can cause, it becomes fairly clear where tectonics are and the amount of sparse data and weak signals that we often have to work with when we're making those decisions. And that helps us understand where we can be data-driven, to use data-driven activities, where we need to be data-informed, we need to combine human and technical models, and where we can be data-inspired. We really just need to look back at the history of how we've used data to be data-driven and data-informed and think about what that means. And we also need to understand what the appropriate tools probably are in these spaces that are going to help us begin to make decisions. So this kind of thinking framework is saying, right, we've got signals. Signals connect things. We see that in graphs. They suggest relationships between things. Excellent point made in an earlier presentation. There are answers that we can and can't get by connecting them, and we have to become comfortable with that, right? Sometimes we're not going to be able to get the answer. And we need to think how we use them, those and the tools they need, and the tools we need. So signals is a particularly interesting problem, especially working in a SOC environment. Trying to figure out how do we use alerting as a partner is a very interesting challenge. Or how do we use recognitions as a partner, which is a term I'll come on to in a moment. It's easy to characterize this as a problem between visibility and recognition. Well, if we had visibility, it would be fine. We'd get recognition, but it's just not that simple. So the model of thinking that we're trying to pursue at the moment, using both technical kind of ML model graphs and the ontologies that we use to describe the business environment, is signals analytics, recognitions, workflows, and notifications. So let me just give you a quick walkthrough of how we put those together. Signals. We typically are going to be working with sets, sequences, or structure of a thing across different time slices, right? So that's one fundamental construct we can use to begin asking, what's the data we have, how useful is it, how do we need to join it together, what are the sources we need to see in concert or individually. From an analytics perspective, we're going to ask, what is the type of analytic we need to overplay over some data, and what is the platform that is best fit to have that data in? This isn't a question of Splunk versus Sumo Logic versus XYZ, right? This is a question of all of them have slightly different advantages based on the thing we're trying to achieve, and ultimately, if we're going to successfully deliver a high-fidelity alert, the probability is that we are going to need multi kind of stacked detections, one on top of the other, across multiple platforms, rather than just A or B. Recognitions. What are we recognizing? Are we using data to recognize left of boom, right of boom, as Sunil Yu talks about, or are we using it to understand those changes in our environment, those changes in the patterns of life across our terrain, the movement, and adversary opportunity? Do we have the right level of zoom? So something else I think a lot about is at the understand level, very often I'm looking to aggregate. I want to see things in aggregate, and then I want to be able to zoom down to an individual thing, and I want to be able to understand how that changes my perception of what the patterns are that I'm seeing, so that I can then go and achieve balance in the controls that I implement, in the patterns that I implement them in. And finally, workflows. So we talk a lot in this industry about high fidelity detections. And if we begin to think about how many of those we actually have from a given tool or multi-tools, it's going to be fairly clear we've got a lot less high fidelity detections than we do low, unless we're really unlucky. And if we think about where we're going to see malicious, suspicious, and benign indicators or recognitions, things that looked different to something, and because they were different, was that an attacker? Things that looked like an attacker at a certain phase, but was it an attacker doing that or somewhere else? We would typically class that in security operations as, oh, that's a false positive of an attacker in my environment. No. That is a signal that tells us about something that was going on. From our perspective of detect and respond, yeah, it wasn't that valuable. But from an identify perspective, that has huge value. There are very few vendors I find in the detect and respond space thinking about how I can make the data that their solution, their sensor, their network probe picks up valuable to my colleagues in IT operations, so that I can begin helping them understand their environment in ways that they didn't before. And ideally, what we would love to do is to also begin to apply that understanding of high fidelity, moderate fidelity, low fidelity over populations of things that are important, that we care about. So a simple model might be like our execs, our VIPs, our super users. If we take the human side, obviously there are machine side, there's application side. The gentleman from JP Morgan who was talking about application flows is this great example of just another application of this. And we can think about those populations in two ways. We can think about slices across them. So I just want to know for this slice of important thing what the attributes are that my recognitions are telling me. Or I can think vertically. I can say, show me the things that are like my CEO's laptop all the way through my organization. Let me begin to understand what that pattern looks like. Finally, that helps us drive changes in our workflows, specifically around notifications and reviews. Because if I know that I'm not going to get high fidelity detections for a certain attack step, path, I'm not going to waste my team's time going after those detections. I'm going to bundle those recognitions, rather. I'm going to bundle those up, and we're going to do a 2-weekly review to look at all the recognitions we had, all the data it was based off of. But if I know that in another area of my attack path, I have very high fidelity detections, we're going to be super focused on a 20-second SLA, for example, like minus 20-second SLA, to Gabe's point about knowing what you've seen, knowing what's probably come after, or knowing what's come before it. And we're going to hopefully be able then to really focus in on how we use our time so that we're not constantly overloaded by these alerts, which have a human cost of context switching and so on and so forth. So finally, a graph, but not a graph that's similar to a lot of the ones we've seen. So as we have begun to implement this thinking in slightly different ways and experiment with it and find out the flaws, one of the things that we've found is immensely powerful is a lot of the signals we get that we can turn into recognitions if we think about them slightly differently give me points of evidence, either about a control or from a control. So from a control perspective, it could be a control gap, a control failure mode, or so on and so forth. And from a control, it will be a bit of telemetry from that thing that picks up that signal. And those things ultimately tell me about assets. Now, an asset could be an entire IT system. It could be a single laptop. It could be a server. I'm interested in taking those recognitions and then abstracting out what my team are able to do when we look at this and understand our environment and say, right, well, we can abstract these points of evidence into facts that we can present to our execs. And I can also extrapolate those out and talk about assumptions from any point of view of a threat model. I can come up with a statement of adversary opportunity based on that pattern. I can apply fair analysis, factor analysis, information risk by Jack Jones to it, and I can issue an advisory. And my advisory is going to be, go implement that. And I would ask, how often is our advisory in this industry based on a true understanding of the business, technical, and project context of the asset that we're looking to protect when we implement that pattern? Because believe you me, there is nothing more painful than not understanding that context, going to implement a control and finding out that that was the wrong move about 8 months too late, by which time you've lost your business support. The project is effectively turned into a sunk cost, but there's really no way back because everyone's committed on that path. But if only we'd understood a little bit more of our environment a bit better. So hopefully this talk has given just a few ideas about this question, which is, for me, one of the most important things. How do I bring my team around a living picture of all these individual models that we hold in our heads that we can't share, we can't get out there, we can't have course corrected. We hold these beliefs, and one day we'll be in a meeting with someone, they'll be like, oh no, that's completely wrong. That system doesn't connect to that. Oh, and there's no firewall there. What do you mean there's no firewall there? Oh yeah, it was in the architecture diagrams, but everyone on this team knows that doesn't exist. Well, hang on a minute, wouldn't it have been great if we could share out those kind of architectural patterns so that we could have identified that using graphs, using maps? And also this question, right? How do I give my business the best possible data to make the judgment call that is best in the situation we're in, right? We don't always have the data we like, but then ideally one of our options, right, is to go and get more data. So it kind of feels that should be where we're getting to with graphs, and I feel that we're beginning to get there. So in closing, when a lot of stuff I've talked about, Gabe mentioned Wardley maps. I haven't put any Wardley maps in here because I feel probably been enough concepts layered on concepts layered on concepts in a kind of nightmarish inception model where you're no longer sure when he spins the thing at the end if the film is over or just beginning. But ultimately, I'm interested in using data to maximize my chances of success in the environment I'm in. What I'm not interested in is this amazing observation, like, as you said, we jumped to technical controls when we could change a process, but how do I know how to do that when it would take me ages to interview all the multitude of teams that are changing all the time as contractors come in and people move from one team to another, and our model is so fluid in so many organizations of who we're working with and who holds what data in their head. How do I get hold of the tools to help me reason through these higher order challenges? Not to say that the work that's being done in graphs isn't immediately immensely valuable, but from a strategy point of view, how do I begin to use that? And I think there's a future for vendors who realize that this is our business problem, and specifically for vendors who provide sensors into our environment. Because if they understand that I want to have that data in a graph format that I can query that is already joined together in a way that understands the ways and the patterns that I want to use that data in to drive change across my environment, we'll be in a much better place. However, until we get to that place, the deal is going to be, I'm going to take the data from your solution, I'm going to put it into my spreadsheets, and I'm going to have to build my own graph, which kind of means I'm doing your job. So hopefully that will change. But yeah, thank you very much. I hope that's provided some insight and ideas, and it's been a pleasure being here. Thanks. I don't know if have we got time?
We have 5 minutes for questions.
Oh, right, okay, sorry. I thought I would have overrun, so I apologize.
So your talk is fascinating, but it's very fast. I hope that you're going to share the slides, so I couldn't take notes.
Yeah,
but,
they're online.
But you touched on a very profound problem, is that SOC team or a security team, IT teams have a tribal knowledge. and they feel very hard to share. I like this statement. And you didn't suggest any tools that can help that, but do you feel like something like social network that is customized towards these teams, that they can share their investigations, ideas, and do some data mining on top of that can help? Have you seen any tools like that or systems?
Yeah, so
Thank you.
this is going to sound like a plug to watch another talk, which you just at the moment might be like, no, please, I can't take it anymore.
Try to model this knowledge somewhere.
Yes, yeah.
So you can query that. So you need something to capture it.
Yeah, so what we built at Photobox to solve this is essentially a system that stores data in Jira. Jira is a great graph database, even though it may not seem like, because it allows you to describe edges and nodes. We built an ontology around describing the form of a business, right? A business has business units. Those business units have different departments. Those departments have different sub-departments. They will have roles within them that have people attached to those roles, et cetera, et cetera. We built a number of ontologies of what I call these building blocks of business, and we've begun to link telemetry and alerts to those areas so that we can understand, for example, this person who uses this account always gets this alert from this SaaS provider to say that their login is suspicious, even though they have 2FA. And over time, I can build up a pattern of life that gives me the confidence to start ignoring alerts, for example. So that there is, I would say, it's not a finished piece of work, but if you want to check out the talk from B-Sides, that has the system that we built, and we've open sourced it. So if you want to grab it, it's all built off AWS Lambda. You can go experiment with it. We built actually a mini company with all this data in a graph. So it's not just typical SOC data that you'd see. It is business unit, business owner, CEO, incident. There's like a whole load of data in there, and you can go and play around with that. And I hadn't seen anything that does that. So we built our own, and we did it through using Slack as a command line and a bunch of other groovy stuff. But I didn't. Ram actually invited me here. He's like, come talk about the stuff in Jira that you did. And then I was talking to Gabe, and Gabe was like, I want to use your talk from B-Sides to indicate how complicated this stuff gets. And I was like, I'm cool with that. But I thought, well, I really need to go and share the thinking behind the talk that we did at B-Sides. So this is like almost the prequel of like, these were all the ideas we were having when we built that, which I didn't get to share in B-Sides. So that's the best answer that I have. But if anyone else has seen anything, I think I saw a fascinating project being done by Sasha Faust's team at Lyft around AWS. They've called it the cartography project, right? A map. I don't think that's a coincidence. So definitely there are other people looking at doing, I think, similar things, especially over changing landscapes.
You can take one more question. All right, let's give it up to Jon.
I think there was one at the back. There's a hand went up. You can just shout. I'm also really jet lagged, so I'm now going to start slowly collapsing on the stage. Maybe I should have bowed out. We'll see.
Hi. Part of your talk seemed to say that we should be moving away from controls and toward processes. And from my observations, processes tend to break when people move teams. Do you have any recommendations on how to strengthen the process as well?
Yes. So I think we have to think about this in terms of timeframes. Where we are today, often we're dealing with legacy processes that have been in place for 20 years, 15 years, whatever it is, and shifting those is very difficult, especially when there's this nightmare mesh of applications that join stuff together which no one really understands, and once you start pulling on one strand, the whole thing collapses. However, if we look at different environments, so Sunil, you again, has a framework that he calls DIE, Distributed, Immutable, Ephemeral, so environments where you can literally tear stuff down and bring stuff up. I think there will be a different ability to change business processes as they rely on technical processes in a few years. I have no particular solution or idea about that now. All I can say is that what I found in a lot of the environments I've worked in is that there was not sufficient understanding of interrelationships and business change programs, either through run, build, or continuous improvement, before security would run in and go, we need to implement something on top of this. There were more elegant solutions to be found by making simple changes. However, digging through the sediment that requires can take 6 months. And by that point, it's too late because you've already started. That's kind of what I was mentioning about implementing other controls on. So we need a better way to dig through the sediment. And we may have to just live with the fact that we need to start building that up ourselves, because security as a function touches every single area of the business. We can get that data, it's just we can't get it today in a scalable way. We have to get it via doing consulting and then putting the consulting in the PDF that no one reads and it's out of date. So it's not a simple problem, but hopefully that is an answer. So yes, thank you very much. Yes.
All right, let's give it up to Jon.
Thank you.
Thank you very much, Jon.